Alright, okay, so we're going to be starting the 10-5 notes, and you don't have to write this part down. I'm just going to give you a brief intro to combinations. I really don't know if you know about combinations, if you've studied them before, so I'll just let you know kind of how they work. So we're going to be talking about combinations here, and you should have your 10-5 note packet, and we'll be getting to that just as soon as I'm done with this little thing on combinations. So combinations are different ways that if you have different numbers of things to choose from, how many ways can you choose? So for example, let's say that I go to an ice cream store and I can get 4 flavors. I can get chocolate, and vanilla, strawberry, and Oreo. Okay, so the ways that I can choose the number out of 4 is one way I could choose is to choose none. So the number of ways that I could choose none would be one way. I could just don't get any. It was one way. Another possibility is I could choose one flavor. So I could choose either a chocolate, a vanilla, a strawberry, or an Oreo. So there are 4 ways to do that. The number of ways I can choose 2 flavors is chocolate and vanilla, chocolate and strawberry, chocolate and Oreo, chocolate and Oreo, vanilla and strawberry, vanilla and Oreo, and then strawberry and Oreo. So there's 6 ways to do that, to get 2 to have 4 and choose 2. The way that I can get 3 is I could get, let's see, I could get a chocolate, a vanilla, and a strawberry, a vanilla, a strawberry, and an Oreo, a chocolate, a strawberry, and an Oreo, or a chocolate and a vanilla and an Oreo. So there are 4 ways to get 3. And notice that when we're doing combinations, order doesn't matter. So a chocolate, vanilla, strawberry is the same thing as a strawberry, vanilla, chocolate. And so with combinations, order doesn't matter. Then last possibility would be, how many ways can I choose 4 of a kind? Well, there's really only one way. I'm going to get a chocolate, a vanilla, a strawberry, and an Oreo. So there's one way to do that. So there's 4 ways. One way for none, four ways to get 1, 6 ways to get 2 flavors, 4 ways to get 3 flavors, and 1 way to get 4 flavors. Okay, so that's combinations is a really big part of what we're going to be doing here. So you should have this page of your notes in front of you. We're going to be looking at the Pascal's triangle. So Pascal's triangle, you may have seen it before. The way you set it up is you have a 1 and then a 1 and a 1. These are just basically different ways of filling in these cells here. So you have 1 and 1, and then we'll have a 1, a 2, and a 1, and a 1, and a 3, and a 3, and a 1. So if you see how this is going, it looks like all these outside ones are going to be 1s, and you're right. And these just keep going. This is our first row, our second row, our row 0, our row 1, our row 2, row 3, 4. And this one goes up to 7, but it really goes to infinity, the number of rows you could possibly have. And then the diagonals, we would have a diagonal right here. This would be a diagonal 1 and diagonal 2 going down this way. So diagonal 1 is always going to be 1. Then diagonal 2 is this one here. It goes 1, 2, 3. And then it looks like, let's do another one. This one comes in and becomes 4, 6, 4, 1. So if you look at how this pattern is going, it looks like it goes 1, 2, 3, 4, and it does. And this is going to be 5, 6, and 7. This one goes 1, 3, 6. Looks like I'm adding 2, then I'm adding 3, and you're right, I'll be adding 4, then I'll be adding 5, and then I'll be adding 6. So let's see what else is going on here. So we have, if we're looking at it going down this direction, it looks like it goes 1, 2, 3, 4, and it does. So this is going to be 5 and a 6 and a 7, and it looks like the outside diagonal out here is all ones, and they are. And so here we're going to add 3, and then we're going to add 6. So this is kind of hard to see what's going on with this one, but we can see that if I have 2 and a 1, I get a 3, and a 3 and a 3, I get a 6, and a 1 and a 3, I get a 4, a 5 and a 10, I get a 15. So the 2 above a cell, if you add them together, will tell you what you get. So I'm going to get a 10 there. I'm going to get a 20 here. This will be a 15. This will be a 35. And this will also be a 35. And what will this be? Right, a 21. So that's how Pascal's triangle gets filled in. Some of these patterns you can see, I've said, you've got the ones on you can list them here, over here. I'm not going to write them out, but we've got the ones on the outside. The first diagonal 2 is consecutive numbers. Diagonal 3 is, it goes up, grows by consecutive numbers. So it goes 1 plus 2 plus 3 plus 4 plus 5 plus 6. Let's see, it's symmetrical if you look at it. It goes 1 1 1 2 1 1 3 3 1 1 4 6 4 1. So the left side is exactly the same as a mirror image of the right side. And so there's lots of different patterns, and see if you can discover some more of them. One of the things you should know about is that each one of these are combinations. These are combinations, and so the rows are combinations. Combination possibilities, another way of saying it. The way that you write a combination is NCR, and that means N is the number that you have and R is the number that you choose out of that number. So for instance, when I was doing the thing about the vanilla and chocolate strawberry and Oreo, I had number of ways that I could choose. 3 out of 4, I'd say that'd be 4C3. 4, choose 3. And I go to my 4th row. This is my row. And this is my diagonal right here. And so the Pascal's triangle can tell us how many possibilities, if you as you recall, the number of ways that I could choose 3 out of 4 is, it equals, there's 4 ways to do that. And so if I go to my 4th row and I go to my 3rd diagonal, this is diagonal 1, 2, 3, and maybe I have a diagonal 0, 1, 2, 3, 1. Yeah, it looks like I have my diagonals off here. So it should be, this should be diagonal 0, and this is diagonal 1 here. And then this is diagonal 2 and diagonal 3 going down this way. Diagonal 0, 1, diagonal 2, and diagonal 3 here. And then I go to my 3rd diagonal, but my 4th row, and it tells me how many I can get if I have 4 to choose from. If you recall that when we were doing the flavors, how many ways is there to choose none? There's 1 way. How many ways is there to choose one flavor? There's 4 ways. The number of ways there was to choose 2 was 6 ways. The number of ways there are to choose 3 is 4 ways, and there's only 1 way that you can choose all 4. So that's what these rows are. They're combinations. It's really a pretty cool thing. Okay, what else can I tell you? Oh yeah, there's another way that you can write NCR, and that is you can write it as N over R. And so N is still the row, R is still the diagonal. And let's see what else I can tell you. I don't know if you noticed it, but this row right here is 1. When you add them, this row adds to 2, this one adds to 4, this one adds to 6, or adds to 8, this one adds, got 4 and 4 is 8, plus 6 is 14, plus 1 and 1 is 16. This is 2 to the 0, 2 to the 1, 2 cubed, 2, this is 2 to the 0, this is 2 to the first, 2 squared, 2 cubed, 2 to the fourth, and so on. So this Pascal's triangle is really pretty awesome. Okay, I'd like you to turn the page. We'll get back to the first page in a little bit, but right now I'd like to expand some of these binomials and see if you can see some patterns going on here. If I have a plus b to the 0, that's anything to the 0 power is 1, so it's going to equal 1. And if I have a plus b to the 1, that's also just going to be itself a plus b. A plus b squared, if I use the box, it's going to give me a squared plus ab, and then plus ab, and then plus b squared. And if I combine them, I get a squared. Okay, so I'm going to combine these diagonals right here, plus 2ab plus b squared. So now if I want to expand it even more, I can do a plus b cubed is going to be the same thing as a plus b times a plus b squared, right? Because you add the exponents. And so I'm going to have a plus b over here, and on top I'm going to have, I'm going to have my answer for the a plus b squared, which is a squared plus 2ab plus b squared. And I'll have a cubed plus 2a squared b plus ab squared. And this one will be a squared b, and this one will be 2ab squared, and then b cubed. And again, I'm going to be combining these like terms. And I'll put my answer up over here as a cubed plus 3a squared b plus 3ab squared plus b cubed. Alright, so then if we're going to do a plus b to the fourth, I can say that that's the same thing as a plus b times a plus b cubed. And this time I'm going to put my a plus b here, and I'm going to put my answer to my a plus b cubed up on top here, a cubed plus 3a squared b plus 3ab squared plus b cubed. And I'm going to pause the video right now, and I'm going to let you do that because it's good practice for you. And when I'll turn it back on in a minute, and you'll be able to check to see whether or not we got the same answer. Okay, so hopefully you didn't just copy mine down and you got a to the fourth plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the fourth, combining all these like terms here. Alright, we're going to do it again. This is going to be a plus b to the fifth, which is going to be a plus b times a plus b to the fourth. And I'll take my answer for the a plus b to the fourth and put it on top here, which is a to the fourth plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the fourth. And I'm going to multiply that by a plus b. Pause your video now and work this thing and see if we get the same answer. Okay, so hopefully you paused it and you worked the a plus b to the fifth, and you came up with a to the fifth plus 5a to the fourth b plus 10a cubed b squared plus 10a squared b cubed plus 5ab to the fourth plus b to the fifth by combining these like terms down here. So do you see any patterns? Look at some of these answers here. It goes a squared, a cubed, a to the fourth, a to the fifth. So that was pretty easy. And same thing with the other end. It's b squared, b cubed, b to the fourth, b to the fifth. How about the things in the in-between here? The second term here is a, b, and this is a to the 1 and b to the 1. This is a squared and b to the 1. This is a cubed b to the 1. This is a to the 4th b to the 1. Third term is a to the 1 b squared. Oh wait, let's start up here. This one up here is just b. Then this is b squared. Let's see. When we have this third term here, we've got 3a to the 1 b squared, and then I have 4a to the 1 b cubed, and then I have 5a to the 1 b to the 4th. So we've got other stuff in between here. Let's see if we're going to make our pattern, what would it look like without having to do all of this multiplying? Let's see if we can figure it out. Okay, so I've written here, it's this a plus b to the 6th. That's what we're going to try and figure out. Now, I guess you've probably seen we've got these coefficients here, like 1 and 5 and 10 and 10 and 5 and 1 and 1 and 4 and 6. Let's ignore the coefficients for right now. And it looks to me like our first term is going to be a to the 6th. And our last term is going to be b to the 6th, but let's wait on that. This one, let's say looking up here. This goes, for the a's, it goes a cubed, 2, 1, and then there's not an a here, but isn't that the same thing as a to the 0, which is the same thing as 1? So there's like an a to the 0 right there. This one goes a to the 4th, a cubed, a squared, a to the 1, and then there's missing a here, but it's really, again, a to the 0. This one's going to go a to the 5th, a to the 4th, a cubed, a squared, a to the 1, and again our missing a to the 0, or our 1 right here. So it's going to work the same way. I've got a to the 6th, now give yourself some room here, plus a to the 5th, plus a to the 4th, plus a cubed, plus a squared, well, I'm running out of room, plus a to the 1, plus, and then a to the 0 is 1, and then let's look how the b's went. I've got no b in the first one, all of these things, I have no b in the first term, but I have b's in the second term. They start as b to the 1, and b to the 1, and b to the 1, b to the 1. So we could say, and that, so we have, but just like you had an a to the 0 over here, I've got a b to the 0. So I've got a cubed times b to the 0, which is 1. So I've got b to the 0, b to the 1, 2, 3. For a plus b to the 4th, I start off, I have no b in the first term, but I do have that missing b to the 0, which is 1, then b to the 1, then b squared, then b cubed, and b to the 4th. This one, I have my missing b to the 0, and then b to the 1, 2, 3, 4, 5. So looks like for the b's here, we're going to be able to say b to the 0, which is just 1, plus a to the 5th b to the 1st, and a to the 4th b squared, and a cubed b to the 3rd, and then b to the 4th, and then a b to the 5th, and then finally b to the 6th. Okay, so that looks like we've got all of our variables here. What we don't have are the coefficients. I'm going to move this a to the 6th over a little bit so I have room for a coefficient. I don't know if you notice it or not, but the coefficients go for this one. It starts out as 1, then the coefficients are 1a and 1b, and then the coefficients for a plus b squared are 1 and 2 and 1, and for a plus b cubed it's 1, 3, 3, and 1, and then for a plus b to the 4th it's 1, 4, 6, 4, and 1. To the 5th, a plus b to the 5th, it's 1, 5, 10, 10, 5, 1. Is anybody seeing where those things came from? Let's look at Pascal's triangle again. Here they are. Our coefficients are, this is 1, for a plus b to the 1 is going to be 1 and 1. A plus b squared, it's 1, 2, 1. A plus b cubed is 1, 3, 3, 1. A plus b to the 4th is 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. For a plus b to the 5th, it's 1, 5, 10, 10, 5, 1. In the 5th row, it's 1, 5, 10, 10, 5, 1. In the 6th row, it's 1, 6, 15, 20, 15, 6, 1. That's what we're going to put for our a plus b to the 6th. It's going to be 1a to 1a. Oh, this should be a to the 6th. Yeah, not ab. It's going to be 1a to the 6th plus 6. I'm just taking this right off the Pascal's triangle. 6 a to the 5th b plus 15 a to the 4th b squared plus 20 a squared b cubed, 8 cubed b cubed plus 15. I'm going to move this plus over here a little bit so I have more room. Plus 15, and then I have 6. That would go right here for 6a b to the 5th, and finally I have 1b to the 6th. So if you can see how this pattern works, you'll be able to do this without having to do all of this arithmetic. And so what I'd like you to do is go back to the first page, and I'm going to see if we can, back to Pascal's triangle, and see if we can come up with some sort of a formula here. Okay, okay, we're looking at, let me make this bigger there. Okay, there we go. We're looking at this box down at the bottom. It's called a binomial theorem, and what we've been multiplying are binomials. The a plus b is a binomial, and for any positive integer n and any numbers a and b. So we can start off like we said, that these numbers in Pascal's triangle are the coefficients, but they're also combinations. So we can write the combination that if we have n number of things to choose from, and we're going to choose n of them, or we're going to choose 0 of them, I should say, then that's going to be the same thing as 1. This equals 1. Because there's only one way to choose 0 out of, doesn't matter how many n's there are. And then it's going to be, so that's the coefficient of the first term for a plus b to the n, and then it will always be a to whatever that n is, a to the n. That's where it starts. Like for instance, when we did a to the 4th, it was a to the 4th, to the 3rd, to the 2nd, to the 1st, to the 0. And then it's going to be b to the 0. That's the missing b that always starts there. And then it's going to go b to the 1, 2, 3, 4. And so that's our first term. Their second term is going to be the number of things you have to choose from. And remember, that number is the same thing as this n right here. NC1, choosing 1 at a time. And then what we're going to multiply that by will be a to the n minus 1. It's going down by 1 every time, and b is going up by 1 every time. So it's going to be b to the 1. The next term is going to be n choose 2, and it's going to be times a times n minus 2. So this is a coefficient right here, and then this is the a term. The b term is going to be, if this is 0 and that's 1, it's going to be b squared. Plus, and then we're going to do a dot, 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 because it just keeps going on and on and on. Oh, I've got to stop. The lights went out. Hold on. Okay, so the lights are back on. And so for finishing this thing up, it's actually easier to start from the other end. The other end, my coefficient is going to be, my combination is going to be n, choose n of them. Like for instance, if I had 4 to choose from, it's going to be 4, choose 4, and that's going to be 1. That will be 1. and then they're going to have our missing a to the 0. That'll always be the last one, and then it will always be b to the nth power. And then going back this way, the one that's just before that is going to be n. The coefficient will be n times c times n minus 1. So if this was 4 out of 4, this will be 3 out of 4, choosing 3 out of 4. And then our a is going to be a to the 1. It's just a to the 1. This was a to the 0. This is going to be a to the 1. And this is going to be b to the n minus 1. So there's little parentheses around here. So the coefficient is nc n minus 1 times a to the 1 b to the n minus 1. And yeah, so that's what it would be. And it's going to be n minus 2 and so on. So you just keep on going until you get down to the very end. So this dot 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 here, this ellipsis becomes dot 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 down here, and this will be the end. So whether or not you understand this really clearly right now or not, it will become more clear to you as we start using them. So let's turn to the third page and try one out. Okay, so now we're on the third page here, and we're going to just do x plus y to the fourth in expanded form. And this is really the same thing that we already did with a plus b to the fourth, but let's see if we can do it without having to actually multiply them out. So the step 1, the power is 4, so we're going to use row 4 of the Pascal's triangle. And writing those 5 numbers, we're going to leave space in between them for variables. So let's see here. Our numbers are going to be, if you look at Pascal's triangle, there'll be 1 and 4 and 6 and 4 and 1. Okay, and then we're going to write powers of x next to each coefficient from left to right, starting with the 4 and decreasing by 1 for each item. So I've got 1 x to the 0, I'm sorry, x to the 1 plus 4 x squared plus, I'm sorry, we're going down. Dang. I'm fixing this. Sorry. We're going to start with x to the 4th with the powers starting with 4 and going down. So x cubed plus 6x squared plus 4x to the 1 plus just 1 x to the 0. And that really is just 1, isn't it? Okay. So now we're going to do this again, and when you're actually doing this, you don't have to do it over and over and over again. You can just do it in one spot, in one line. But now we're going to write the powers of y next to each power of x from left to right, starting with power of 0 and increasing by 1 for each term. So right now I have x to the 4th, and then I have y to the 0, and then that's plus 4x cubed y to the 1 plus 6x squared y squared plus 4x cubed y cubed. I got that wrong. X squared x1. This should be x to the 1. 4x, which is x to the 1. Then y cubed. And then plus 1 x to the 0, y to the 4th, which is just y to the 4th. Okay, and then we just simplify by omitting coefficients and exponents that equal 1. So for instance, I can just say, oh, this should be up here, should be x to the 4th. I forgot to bring it down from up there. So this is going to be x to the 4th, y to the 0 is just 1, plus 4x cubed y, because that's y to the 1, plus 6x squared y squared plus 4x, just x because it's x to the 1, y cubed plus y to the 4th. And that's what we're looking for. So this right here is Yeah, x plus y to the fourth is this thing right here. Okay, and then we're going to go to the fourth page and see if we can work some problems. Okay, you should be on the fourth page of your packet, and we're going to use the binomial theorem to try and find the binomial x plus y to the seventh power. So n is going to be 7. And for our coefficients, we're going to use the seventh row of the Pascal's triangle, which if you look at it is 1, 7, 21, 35, 35, 21, 7, and 1. And so these are the coefficients, and we're going to start with x to the seventh because n is equal to 7. And so it's going to be 1x to the seventh power times y to the 0, which is just 1. So this is our first term here. Then it's going to be plus, our coefficient is 7. The x's are going down now, so 7 or x to the sixth, then y to the first. And then plus, the next coefficient is 21, x to the fifth, then y squared. Y's are going up, x's are going down. Plus 35, x to the fourth, going down, y cubed, going up. Plus 35, x cubed, and then y to the fourth, plus 21, x squared, y to the fifth, plus 7, just x, y to the sixth, plus 1 times x to the 0, which is also 1, times y to the seventh. And that's what the expanded binomial is of x plus y to the seventh power. Looks like I need to make it a little bit smaller here. Okay, so now it gets a little, the plot thickens here. It gets a little bit more complicated, although this time n is only going to be equal to 5. So we're going to go to the fifth row of the Pascal's triangle, and that fifth row is 1, 5, 10, 10, 5, 1. And so our first term is going to be like a minus b, and a is going to be 3x, and b is going to be 2y. So wherever we had those before, we have to put them into parentheses. So our first coefficient is going to be 1, and it's going to be 3x to the nth power, which is 5. So 3x, but then we have to put that in parentheses, and then times y to the 1, or negative 2y to the 0 power. So we don't have any y's in that one. Then it's going to be minus or plus, let's just do this for right now, plus a negative 2y. Let's go back. Sorry. Our coefficient is going to be 5. And our x's are going to be 3x, and it's going down to the fourth, and then our y's are going to be negative 2y, and that's to the 1 power, so it's just negative 2y. And then that's going to be plus our next coefficient, which is 10, and then 3x, it's going down, cubed, but the y's are going up, so now I have negative 2y squared. Our next term will be the next one on line, which is another 10, then 3x squared, and then negative 2y cubed going up, and then our next to the last one will be plus 5, that's that 5 right there, times 3x to the 1, and then negative 2y to the fourth, and then finally plus coefficient 1, which we don't have to write, times 3x to the 0, which is also 1, times negative 2y to the fifth. So it's very important that you have these parentheses, and you'll see why, because we have to, this is what you have so far. Now we have to simplify this. First of all, we have 3x to the fifth. Well, that's 3 to the fifth. 3 to the fifth is 243. x to the 5th. So our next term right here is we have a negative 2 to the 1, so that's negative 2 times 3 to the 4th times 5. It's going to be negative. Our answer is going to be negative. So first of all, I've got 3 to the 4th, and 3 to the 4th is 81 times 5 times negative 2, and that equals 810 times 3x, wait a second, times x to the 4th, because the 3's in there, times y, because it's just y to the 1. And then I'm going to add to that plus, this is going to be, our next term is going to be negative 2 squared, which is going to be positive, then times 3 times 10. So I've got, this is 4 times 3, which is 12, times 10 is 120. Oh, but wait a second, I've got 3 cubed here. That's 27. So it's going to be 27 times 4 times 10. If you do that in your calculator, you're going to get 1080. And that's going to be x cubed and then y squared. So that one's positive. Our next term right here is going to be negative 2 cubed, which is going to be negative. That's a negative 8. And that's times 3 squared, which is 9. And that's times 10. So that's going to be negative 72 times 10, which is negative 720. Then it'll be x squared, and then it'll be y cubed. Our next term over here is negative 2 to the 4th. Well, that's going to be positive 16 times 3 times 5. And that works out to be 240. But it's going to be positive. And that's going to be just x to the 1 and y to the 4th. And then our last term down here is negative 2y to the 5th. Negative 2 to the 5th is negative 32 y to the 5th. So this is what our final answer is right here. So there's some multiplying. Good thing you have a calculator. You can do this. Okay, then on this example 3 then, you're going to have questions where they're going to ask, say, use a binomial theorem to find x plus y to the 12th. Find out what is the term, these are all different kinds of terms, what term is going to have y to the 5th in it. So you're going to need the coefficient, and you're going to need to know it's going to be y to the 5th, but it's going to be x to the what? So that's the question. So we know that it's going to start with x to the nth, and in this case, n is equal to 12. It'll start as x to the 12th, and y is going to start as y to the 0. And after that, it just starts working its way up, or working its way down for the x's and up for the y's. So it'll be x to the 12th, 11th, 10th, 9th, 8th, 7th, and 6th, and so on. The y, ... The y's are going to go 0, then 1, 2, 3, 4, 5. So this is the term that's going to have y to the 5th in it. This is going to be x to the 7th, y to the 5th. And then the coefficient is going to be n, which is 12, choose 5. This is the number that you'd be choosing, 5. So then we don't have a 12th row on our Pascal's triangle, and we don't want to make one. We want to be able to figure out how to do it. And so what we're going to do is we're going to use our calculator. This is a TI-84, and so the way you do it with this one is you go to Math. We're going to find 12C5. 12, choose 5. And so we're going to go to Math and go to Probability. You can arrow to the left, and it'll go right to Probability, and then number 3 is NCR. Hopefully you can see this. So I'm going to push 3. And, oh, I've got an answer, and I have to clear this whole screen. Okay, let's do this again. I go to Math, and then Probability, arrow over to Probability, and then go to number 3, oh, I forgot. This is different than Inspire. The Inspire, you put in NCR first, then you put in your N and your R. With this one, you put in the N first, which is 12, and then you go to Math, Probability, number 3, NCR, and then you push 5 like that, and you push that number, and you get 792. So this works pretty well with these calculators. So this is going to be 792 x to the 7th y to the 5th, and that's the answer to this question. They want to know what term has y to the 5th in it, and that's it. Let me show you how it works with the Inspire. Okay, you're on your scratch pad, and I think I'll make it a little bit bigger. So yeah, and I better do a focus on this. Okay, so on this, you're going to let's see. You're going to go to your menu, and number 5 is probability, and you're going to go to combinations number 3. So now you have an NCR there, and now you put in your N and comma R. So N is 12, comma is right down to the left of your O button down below, and 5, and then close the parentheses, and then push enter, and you get 792 again. That's the way you do it with the Inspire. Okay, let's stop for a sec. Okay, for our last example, we want you to read the problem on page 628 under Y. And so I'm just going to read it to you. If you are on page 628, it says, Y. Suppose a biologist studying an endangered species of gibbon has found that an average 80% of gibbon offspring are female and 20% are male. So zoo workers anticipate that their captive gibbons will produce N offspring, an unknown number, and want to know the probability that none of these offspring will be male. The biologist can use a term from the binomial expansion of 0.8 plus 0.2 to the n to solve this problem. So that's what we have right here. This is the probability, except for if this was n, it would be an unknown number of them. But the probability of it being a male is 80%, and probability of being a female is 20%. So this is one way to say it. Then this is a combination. So you can either have a male or a female. All right, so I want to do a really quick review about a couple of probability concepts. One is, if you want to know the probability of, say, A and B happening, you know, like you're going to draw a king and you're going to draw a queen when you draw 2 cards. That's that kind of a situation. Then you could say that this is the same thing as a probability of A times the probability of B. But if we have a situation where it's the probability of A or B, in other words, you're drawing 1 card and you're going to draw a king or a queen, then what you do with those probabilities is you add them. So OR means add. When you multiply probabilities, since they're both fractions, the probability is going to be much smaller than if you do something or something else. Okay, so we're going to get back to that. We're going to be using both of these concepts in what we're doing here in this problem here. So first of all, what they want to know is, they say, what's the probability that a gibbon has 5 offspring? They have 2 males and 3 females. So if we do the way we choose them, we can say that n is equal to 5, and we're going to choose 2 males. But you think, well, can't we also do 5 choose 3 females? Well, if you look at your Pascal's triangle, 5C2 is 10, and 5C3 is also 10. In other words, the probability, or the number of ways that you can choose 2 males and 3 females, is the same thing. They both equal 10. So that's what we're going to use when we're going to be we're going to find the term in this binomial expansion of 0.8 plus 0.2 to the 5th that'll have this situation where you have 5 and you're choosing 10. So we know that if we're going to choose 2 males, we're going to have it's going to, when we start expanding this, it's going to be 0.8 to the fifth times 0.2 to the 0. That's how we start. And our coefficients are going to be, it's going to go 1 and 5 and 10 and 10 and 5 and 1. So this is 1 times 0.8 to the fifth times the female. This is 1 male. And so this is our first term here. And then it's going to be plus 0.8 plus 5, which is our coefficient here, times 0.8 to the fifth times just 0.2 to the 1, or 0.2. And then we're going to go to the next one, which is going to be 10 times females, for males. Oh, I made a mistake here. This should be 8 to the fourth because it's going down. This is to the fourth. So this is 4. This is 5 males. This is way you can get 5 males. There's only one way you can get all 5 males, and this is a probability. Then, so it'd be 0.8 to the fifth. That's be the probability of getting all 5 males. Then this one tells you the probability of getting 4 males and 1 female. Then this is going to tell you the probability of getting 3 males and 2 females. So this one's going up and this one's going down. And then this is going to tell you the probability of getting 2 males, 0.8 squared times 0.2 cubed. And then our last one is going to be the probability of getting, let's see, I guess I'm missing one here. I got 5, 4, 3, 2, and 1, 2, 0, 1, 2, 3. Oh, I'm missing, oh, I know my mistake is. I forgot. This is 1 and 5. Our coefficients are 1, 5, 10, and this should be 10. It's hard to talk and do this stuff. Okay, and then plus, then our next coefficient would be 5, and that would be times what number of ways of getting 1 male, which is 8 to the 1, times 4 females, or the probability of getting 4 females. And then finally, it's going to be the probability of getting all females, which is going to be 0.2 to the fifth. Which is, yeah. Okay, so what we care about is the probability of getting 2 males and 3 females. So that would be this one right here. And which also is the same probability. Yeah. So what we're going to do is we're just going to multiply this out, and it's going to be 10 times 0.8 squared times 0.2 cubed. And so that'll be 10 times, let's see, 0.00512 That's what you get when you multiply all this out, which equals 0.0512, or about 5.12% probability that they're going to have, if they have 5 offspring, that 2 of them are going to be males and 3 are going to be females. So this is a little complicated, but basically if you use a binomial theorem where it's kind of this would be males and this would be females, and you have 5 babies, you could just kind of line it out this way and expand it. This is I'm going to try and explain how this kind of works with probability. If you have 5 babies, if the mom has 5 babies, she's going to have a male. This is one possibility. She'll have a male and then another male and then 3 females, and they just come out in that order. The probability for this one is 0.8 times 0.8, then times 0.2 times 0.2 times 0.2. So the probability, they're going to have that one and that one and that one and that one and that one. So when you have probabilities of and, you multiply them all, which is 8 squared times 2.2 cubed. And when you do that, you're going to get this number right here, 0.00512. But that's not the only combination that you could possibly have. You could also, she could also do it this way. She could do it as have a male and then a female and then a male and then 2 more females. That's going to have, since you're multiplying the same things, that's also going to have the same probability of 0.00512. Or another possibility would be she could have a male and then a female and then a female and then a male and then another female. So she still has 3 females and 2 males, and that would still have the same probability, 0.00512. Well, we've seen that the number of ways that you can take and have 5 and choose 3, or 5 and choose 2, there's 10 different ways. So I could write out 10 different rows of these, and they would all have the same probability. I'm not going to do it, but they'd all have the same probability of 0.00512. So in other words, she's going to do either this combination or that combination or that combination or that combination. She's not going to have 50 babies. She's only going to have 5 babies, but she's going to have either in this order or this order or this order or this order or this order, these different combinations. And since there's 10 different ways of doing it, you multiply this times 10, because she's doing it that or this one or that one or that one or that one. And so if you have the probability of something or something else, you add those probabilities. But the quick way of adding is by multiplying by the number of times you're doing it. So instead of adding them 10 times, we'll just multiply by 10. And that's what this coefficient is right here. That tells you the number of ways that you can get this probability of male, male, female, female, female. So your homework then is, this is actually not, yeah, this is your homework right here. And so it won't be your homework. We're going to do this as classwork. Yeah. So this is your 10-5 notes. Hope that has been something you could understand. We'll work on it in class.